students, let us start our discussion about alternating current. Alternating current is that current which varies its magnitude with respect to time and also change its polarity. That is, one time it becomes positive and other time becomes negative. And if we want to represent this current on the graph, then if this we take as a time axis, then if this axis represents the magnitude of the current, it means this axis represents the alternating current. Then when current starts flowing through any circuit, then at an instant of time the current varies its value with respect to time. Suppose that at any instant of time it reaches at its maximum value, that is Im, and at any other instant of time the current reaches its maximum value in the negative direction, that is minus Im. So if we want to plot a graph for the alternating current, then first you should to know what is the expression that provides us the knowledge about the alternating current. So at any instant of time t, the instantaneous current can be expressed as I equal to Im sine omega t. Okay, so where t is instantaneous time at which the maximum value at which the value of the alternating current is I, and Im is the maximum value of the alternating current, and here omega is the angular frequency of alternating current by which the alternating current changes its polarity with respect to time. So if you plot a graph between t and I, then we get a particular. Suppose that this time is t by 4, this one is t by 2, this one is 3t by 4, this one is t, and so on. So here t is the time period. It means the time in which the alternating current completes one cycle. It means if current starts at this point and reaches at this point, the both point have in same phase. It means at this point it is going to upward direction in positive region, and at this point it is also going in upward direction and positive region. So all these 2 points are in same phase. The total time taken by the current to reach from this position to this position is known as time period. So if we plot a graph, then we get now, as we know that omega can be expressed as 2 pi by t. So I is equal to Im sine 2 pi by t into t. If we put the value of small t as t by 4, then we get I is equal to I t by 4. It means this becomes sine 90, sine 90 becomes 1. So the graph is find out like this, something this, if you plot this. Okay, so this is the representation of the alternating current. If we plot a table for drawing this, then you can take at t at here and omega t at here, then I at here. Then after taking t is equal to t by 4, what becomes value of omega t? It means this becomes t by 4, it means this becomes pi by 2, and I becomes Im. If you take this as t by 2, then you get this becomes pi, and we know that sine pi is equal to 0. Again, if we put t is equal to 3t by 4, then we get this is 3 pi by 2, and again at 3 pi by 2, the sign of 3 pi by 2 is minus of 1, so I becomes minus Im, and if you put t, then at t, this t and t will cancel, sine 2 pi. Sine 2 pi means sine 360. So the value of omega becomes 2 pi by t, and if we put the value of t as t, then this value of omega t becomes 2 pi. Now if we put the value of this omega t as 2 pi, then we get I equal to Im sine 2 pi. Sine 2 pi means 0, so I becomes 0. Okay, so you have got that the data for I with respect to different value of t, and you can plot this graph. This is known as sinusoidal graph or sine graph, and you are seeing that the amount of the current varies with respect to time, and after certain time interval from here you are observed that the alternating current changes its polarity with respect to time. One time it gets in positive region, and other time it is found in the negative region. Okay, so this is the basic concept of the alternating current. As we all know that the alternating current can be produced due to the help of the alternating voltage source. So let us talk about alternating voltage source. Okay, so what will be the nature of the alternating voltage source, and what are the real alternating voltage sources? As we know that the alternating current generator, AC generator, which I have told you already, AC generator is the source of the alternating voltage source and alternating current also. So alternating voltage is just similar and can be expressed by the equation V equal to Vm sine omega t, and here Vm is the maximum value of the voltage and omega t is the argument of the sine. It means omega represents the angular frequency of the voltage source by which the voltage or the terminal of the potential source changes its polarity with respect to time, and t represents the time at which the value of the potential obtained as V. Okay, this V is the instantaneous value of the potential. Now if we plot a graph for this also, then we get similar graph for this potential, and this graph represents the potential provided by the potential source. Okay, so this is all about the basic concept related to the alternating voltage source and alternating current source. Now let us study about what happens when a resistor is connected to a AC source. Okay, let us start. So let us start discussion about AC voltage source applied to a resistor. For this, let us suppose that we have a resistor of resistance R ohm, and this is connected to a AC voltage supply whose instantaneous potential at any instant of time t is given as V equal to Vm sine omega t. So as we supplied a potential across the terminal of this resistor, then we can find that there is a current flowing through the resistor. And what will be the value of the instantaneous current in terms of the sine omega t? So let us find out this. As you know that according to Ohm's law, when there is a potential applied across the terminal of the conductor, then the current flowing through that conductor can be given by the formula V by R. So as V is equal to Vm sine omega t, then I is equal to what? I equal to V by R. It means Vm by R into sine of omega t. Okay, so if we write this Vm by R as Im, as we know that when the potential is maximum, then current is also maximum through the resistor. So Vm by R can be expressed as Im, so this becomes Im sine omega t. This is equation number 2. From first equation and second equation, we are seeing that the voltage and current both are in same phase. It means the argument of the sine omega t in the voltage is same as the argument of the sine omega t in the current. equation. Okay, so if we plot a graph for the representation of voltage and current on a single time axis, then this is the current and voltage line. Then as we know that if you plot the graph for different time interval, that is for t is equal to 0, t is equal to t by 4, t by 2, 3t by 4 plus 3t, 5t by 4 and 3t by 2 and 7t by 4 and here 2t. Okay, so you can plot it as, suppose that this is the value of plus Vm and this one is the value of minus Vm and this one is the value of plus Im and this one is the value of minus Im. Then you can plot the graph for potential and the current simultaneously on this single graph. So if you draw a table and putting the value of t, then you can also find out different value of v at different value of t. Okay, so if we plot the graph for the potential and current with respect to time, then you get like this graph. This is for potential. Okay, the potential varies its polarity continuously. Also if you plot the graph for the current, then we get, this is the graph for the current. Okay, you are seeing that in this graph current and voltage both are in same phase. It means when the voltage reached at its maximum value in positive phase, positive direction, then current is also reached at its maximum value in positive direction. When voltage becomes 0, then current also becomes 0. Similarly, when voltage or potential difference reached at its maximum value in the negative direction, then current is also reached at its maximum value in the negative direction. It means the voltage and current are in same phase. When voltage increases, then current increases. When voltage decreases, current decreases. So we are seeing that the voltage and current both are in same phase. This represents the V equal to Vm sin omega t, and this graph represents the I equal to Im sin omega t. Okay, now let us talk about the power dissipated in the resistor in one complete cycle. As we know that alternating voltage source and alternating current source changes its polarity with respect to time. It means after particular time interval it repeats its value. So in a particular one cycle from here to here, how much time? This is t. So in time t, how much power dissipated across this resistor? Let us calculate. As we know that from this equation, the instantaneous power drop in the resistor is given by the formula V dot I. It means Vm sin omega t dot Im sin omega t. So from here this becomes Vm Im sin square omega t. This is the instantaneous power loss in the resistor. So what will be the average power drop? What will be the average power drop in one complete cycle? It means how much power drop in one time interval, it means t. So how much time, how much power dissipated in time t? So this can be calculated by taking the average in time t. It means 0 to t Vm Im sin square omega t dot dt. Now from here we are seeing that Vm and Im both are constant, so can be taken from outside the integration. This becomes Vm Im by t 0 to t sin square omega t dot dt. Now let us find out what will be the value of the integration 0 to t sin square omega t. So the value of 0 to t sin square omega t dot dt will be find out with the help of, as we know that sin square omega t can be expressed as 1 minus cos 2 omega t whole by 2 dot dt. So this becomes 1 by 2 dt 0 to t minus integration 0 to t cos 2 omega t dot dt by 2, and this half can be taken from outside integration, and integration of dot dt 1 dot dt becomes t. So t, putting lower and upper limit at this value, and as we know that 1 by 2 can taken outside from the integration, this becomes cos 2 omega t dot dt. So this becomes t by 2 minus this becomes 0, as we know that the average of the cos omega t, average of the sin omega t is always 0. So this is t by 2. So if we put the value of this equal to t by 2, then we get average value of p is Vm Im by t into t by 2. So this t and this t becomes cancel each other, and average of p is equal to Vm by 2 dot Im by 2. So this is equal to Vm by root 2 dot Im by root 2. Okay, so the average value of the power dissipated in the resistor applied to AC volt source, connected to AC voltage source, is Vm by root 2 dot Im by root 2. This Vm by root 2 is termed as a new term known as Vrms dot Irms. So average value of the power dissipated in one complete cycle across the R is Vrms dot Irms. What is Vrms and Irms? Let us discuss it. So as you get the average power loss in a resistor applied, which is connected to a AC source, is Vrms dot Irms. It means if the resistor is connected to an equivalent DC source, suppose that this is the resistor whose value is same as that of the resistor connected in AC source, and it is connected to a particular DC source, and in that same time if we connect this DC source whose value is nearly equal to I and the current flowing through that is R, and the same amount of power is dissipated as is the power dissipated in one complete cycle in the resistor in AC source. Okay, so this P is comparable to this I dot V. It means P average in AC is comparable to P in DC. So this becomes VDC dot IDC. It means Vrms dot Irms is equal to VDC dot IDC. It means, okay, so Vrms is equivalent to VDC and Irms is equivalent to IDC. Okay, this is all about the AC voltage applied to a resistor. Tomorrow we will discuss the AC voltage applied to a inductor and a capacitor. Okay, so till now take care. Thank you.